to the lunar surface, drive more than 500 meters, and send back high-definition data. Now, what happened? We started out developing our rover. You can see in 2007 it was rather bulky, and then we started to use more and more COTS components in order to make it light. So our main priority was to really make it very light. And now with 4 kilograms, we have the lightest planetary rover in the world. In 2015, we won a $500K mobility milestone prize, and that was the very first time that the international press got aware of iSpace. And we ended up being one of the 5 finalists out of 34 teams in March last year when the prize was cancelled because no private company was ready to go to the moon by then. However, even if we didn't win the prize, it taught us one very important lesson. So we started out developing only the rover, which was a risky bet because we thought we could rely on a third partner to deliver our rover to the lunar surface. Now what happened is that during the X Prize we weren't able to find a partner who could bring us, so we teamed up with the Americans and they ran out of money. Then we teamed up with the Indians, so we had actually already sent our rover to India, and then they also ran out of money. So that really taught us, okay, if we want to make it to the moon, we have to do this lander ourselves. And that's when we started developing our lander, which you can see here. Also, the Google Lunar X Prize helped us build a very strong partner network. So you would see companies like Japan Airlines. Japan Airlines is today one of our key investors. You would see Suzuki, and then others that you might not know. So you would have Semedyne. Semedyne helped us reduce the weight of our rover because we could replace the screws by their adhesive, and we would space qualify their glue. Similarly, Zoff is an eyewear manufacturing company, and we are using the material of the frames that they would use for their glasses because it's heat resistant, lightweight, flexible material, so we are using that for our wheels. So that is how we started forming partnerships in the context of the Google Lunar X Prize, and from there our team kept growing. And today we are a global company with 3 offices. Our headquarters is in Tokyo, where we have about, between 50 and 60 people. We have one European office that we opened in March 2017 that is based in Luxembourg, and we have a presence at NASA Ames in the US. And we all share one and the same vision, which is to expand human presence beyond Earth. And the way we are going to do that is basically we have to be successful in 3 different stages. So first of all, we will have to implement our first commercial mission to the moon successfully. In a second step, we will have to build a high-frequency and low-cost transportation system to the moon and gather data well ahead of our competitors. And then in a third step, which will start in the 2030s, we will also use the resources that we would find on the moon through a multi-rover system. Now this gives you a bit of an idea what our missions will look like. We are going to launch with SpaceX, so we will be on 2 Falcon 9s, and we will be launching from the US, obviously. So these contracts have already been paid for 2020 and 2021. As you can see here, our lander, so our orbiter in the first mission, will be ejected and will enter lunar orbit and then orbit around the moon and send back data. So this is a technology demonstration mission where we want to validate our technology. And then in the second, which is also a technology demonstration mission, we will demonstrate how we will land on the moon. Ideally, it is a flat surface without any hazards like craters or large rocks. And then this lander will deploy 2 of our rovers. So this is what we call the mother rover, and inside it would carry a child rover that you will see here. And this child rover will help us to get into the more difficult to access lunar caves and lunar lava tubes. So this is very much what our first 2 missions, Hakuto R, will look like. you may be wondering, what does it have to do with AI? How are we going to use AI in those two first missions? For M1, it will basically be, essentially be AI for fault detection during the flight. So this will allow us to identify any potential problems of the spacecraft at an early stage. So early warning, which is very important for us. And then post-mission, it would be imagery processing, so that we could, for instance, generate this type of map. So this is one from NASA. As I said, we're just preparing for the first ones, but this is what we wanted to look like afterwards. So all the green dots you would see here would be hazards, craters, and big rocks, and this will eventually help us identify a good landing site for our second mission. And then in M2 in 2021, which is the landing mission, we will basically use AI to increase our rover's autonomy. So it will help us in terms of data processing, in terms of localization. We will be able to generate maps on board in order to avoid to send them back to Earth and then send them back again. And also for autonomous path planning, we will be using AI, which also increases the speed of decision making. Now, what makes commercial space resource utilization like ours successful in the end? A first preliminary success that we are observing in our industry is that more and more space agencies are looking at what commercial players, the smaller ones, are doing, and they organize their missions and would also ask commercial players to provide services to them. So we see that with NASA, with the Commercial Lunar Payload Service, and we would also see it with ESAs, so the European Space Agency's in situ resource utilization demonstration mission, which is essentially about proving by 2025 that it is feasible to produce water on the moon. So this is a first step, so I think we will be starting out with strong public-private partnerships. So this is very much a collaboration between the public and the private sector. But eventually in the midterm, of course, our success very much depends whether we are able to move away from the move away from those public-private missions and really shift to the purely commercial missions. Now you saw the Moon Valley in that video. In order to create this Moon Valley, we will have to exchange with other industries that have nothing to do with space, and we've been doing so in the Google Lunar X Prize. So at some point we will need energy on the moon, we will need infrastructure, we will need mobility on the moon, telecommunications. So now is the right time to engage with those stakeholders. And as I said, we've done so during the Google Lunar X Prize, and now for Hackathon R, basically, which means Hackathon Reboot. So our two first missions, we already have 3 corporate partners, so we would have Japan Airlines, then NGK Sparkplug, with whom we will make the first experiment with a solid-state battery on the lunar surface, which is very key for our continued power supply. And then we are also partnering with a large insurance group in order to look at how can we ensure high-risk missions like the ones we are doing. Then very important for us in the mid and long term as well is an international legal framework for the utilization of space resources. You might know that Luxembourg created a legal framework for that. You would also know that there is a US law about the commercial utilization of space resources. But these are national initiatives, and eventually their legal standing will at some point be questioned. So what we're hoping for is that the UN is making some progress on establishing a multilateral framework for these activities. And what we are doing at iSpace is we are contributing to the Hague Space Resources Working Group, which is an international open public-private forum where you would have China, Russia, and all the big nations sitting around one table and talking together and elaborating ideas what these rules could look like. And then impact, of course, any business today needs to be sustainable, needs to make an impact, and that is the same for us. If we want to have the civil society support, we will have to tell people to what extent we are making impact. One example would be for medicine, for instance. In space, in low gravity on the moon, you would have a better crystallization of proteins, which helps develop new medication. And then you were talking about education before. I think space and lunar exploration are very inspiring activities, so that's also where you can excite young people for science, technology, engineering, and mathematics. And there's many more. Now, what have we concretely achieved so far? As you've seen, we have booked our launches with SpaceX for our first 2 missions. We have passed preliminary design review, which is the first technical system review in our field, where we had 26 experts from Japan, Europe, and the US telling us that our design is okay and that we can go on. And we are moving towards the second one, which will take place in April. We have global collaborations, be it in the US, in Europe, and in Japan. We were selected 1 out of the 9 teams that are able to bid for NASA's commercial payload service to the moon, which is a $2.6 billion contract which runs over 10 years. Then, as I said, we have already 3 corporate partners for our 2 first missions, and eventually we also raised 80 million euros in December 2017, which is the largest Series A investment in Japan and also among the largest in the global space resources industry. Now this is going to finance, it's basically the working capital for our 2 first missions. It's paying for rover and lander development, human resources, and the 2 launches. The interesting thing here is, as you see, the money is on the one hand public. It comes from the Development Bank of Japan and INJ, which is a public-private VC. And then on the other hand, you would have all those corporates. You would, for instance, also have KDDI, which is the 2nd largest telecoms provider in Japan. They are interested in setting up the telecommunications infrastructure for us to learn more about the communication between the rover and the lander. You would have Shimizu, which is a large construction and engineering group. They have been doing research and development on a lunar base for 10 years. And now we are taking them to the moon so that they could actually better assess which type of equipment and materials they would have to use once we will need infrastructure up there. You would also see Topan. So we are using their silver Teflon coating for our rover, and we will space qualify it. So this is very much the way we work with our partners, be it sponsors, be it investors or technology development partners. We try to create maximum value for both sides. Now eventually, and this is my last slide, the way we define success, I think iSpace will be successful when we can tell the world that we have triggered a revolution in space exploration, that we have brought down costs, and that we have made the lunar surface accessible. The second is that we have created a new marketplace with space resource utilization as a catalyst. And eventually that we have expanded human presence beyond Earth. Thank you very much for your attention.
Thank you, Lynn. Thank you very much. Let's move over there. Was viele nicht wissen, Lynn kann eigentlich genauso gut Deutsch wie Englisch.
Das ist ein bisschen eingerostet.
Weil sie wollte nur auf Englisch halten, weil sie die vielen Fachbegriffe lieber auf Englisch. Wir werden gleich wieder auf Englisch switchen, aber ich sage es noch kurz auf Deutsch zu Ende. Sie hat an der TU München studiert. So I'm wondering, how did you end up after university later in space business?
Well, I've always had an interest in macroeconomics and Schumpeter's creation creative destruction. So I joined the Luxembourg Chamber of Commerce about 5 years ago.
Okay.
And I was always waiting for Luxembourg to find this one niche that would make a difference. And so when Luxembourg set aside 200 million euros for new space companies, and in particular space resource utilization companies, I thought it would be a very exciting new area. And then it was in November 2017, we had a state visit to Japan where I saw this vision video for the very first time. And I thought, wow, okay, these guys are pretty crazy. But then the more I learned about them, and it was about a couple of weeks later that they raised 80 million euros, I thought, okay, they are serious about this. And the more I learned about the company, the more I wanted to join it.
So you called and they...
More or less.
Very good. Very interesting. So 80 million is a lot of money, but with 80 people, it will be over pretty soon. So I'm wondering, how exactly is your business model? So how will you guys earn money?
Yeah, right. So our objective in the end will be to find water on the moon, split it into hydrogen and oxygen, and then produce rocket propellant. And the United Launch Alliance has already publicly announced that they would buy the 1 kilogram of water from us on the moon for $500 per kilogram and for 3,500 euros per kilogram for low Earth orbit. So there's definitely customers there. Obviously, in terms of investment, it's always long horizons and risk tolerance.
Yes, because it will take ages until you guys will...
Exactly, and that's where short-term monetization is very key. So the way we are doing this, we sell branding partnerships, we sell joint technology development partnerships, we transport payload to the moon, so in that sense we are a logistics company as well, selling this service.
Yeah.
So that is how we are going to monetize. In the short term, before being able to use the resources we will find and sell these.
When will you be cash flow positive? Any plans about that?
Over the next couple of years.
Okay, the moon is very interesting in the space business. There's also talks about other places. Do you plan to go to other places as well?
No, our focus is really on the moon. I mean, we would love to go to Mars as well. There's probably very interesting resources on Mars.
Elon Musk has big plans.
Yes, sure. But I mean, it's an extremely complex journey. The distance between Earth and the moon is about 380,000 kilometers. The one to Mars is 54 million kilometers. So it's not only a much more complex journey, but it also comes, for instance, with issues like communications delay. So currently, to the moon, it will be around 1 second, 1.25 seconds. But then for the moon, for Mars, it can go up to 22 minutes. So you can see the difference. It's much more complex to go to Mars than to the moon. And then asteroid mining is also rather complex because, first of all, it's very hard. It's difficult to spot them because they're so small. There's very little scientific knowledge about these. Yeah.
Are there any? Haben wir irgendwelche Zuschauerfragen?
Ja, haben wir. Es sind mehrere. Aus Zeitgründen können wir wahrscheinlich nicht alle beantworten, aber ich starte mal mit der ersten Frage, jetzt wieder auf Englisch. Some people are afraid that civilization on the moon will be the initiative for the first space war, especially cyber war. To what extent do you invest in defense?
Well, our approach is more to invest our time in collaboration, in international collaboration. As I said, we are actively contributing to the Hague Space Resources Working Group. Our managing director is the chair of the technical panel where we are talking about things like, well, if my lander lands here, how much distance must there be between yours and mine, about safety zones, about any type of things that are not clear at this moment. Frequency allocation, for instance, is also an issue. So far we can use the frequencies that are used for R&D purposes. As soon as this becomes a commercial activity, we will have to ask for new ones at the International Telecommunications Union. So we are more looking at finding solutions than defending ourselves.
Yeah. Okay. Okay, that's it. All right. Just one last question from my side. So, how long will this the time frame be from finding water and starting civilization on the moon? And how much funding do you need until then?
Yeah, I mean, we are expecting to start space resource utilization, so extraction and utilization activities in the 2030s. And as you could see in the video, by 2040 we are expecting 1,000 people to live on the moon and work on the moon, with 10,000 visiting, so space tourists basically. And obviously right now we are preparing for our B series, so obviously it is a capital intense market, so we're looking for global money as well, so yeah.
Okay, thank you very much.
Thank you very much.